So this is the last video for 1325 chapter 12.4. We have a work problem here. In Silicon Valley, a number of computer firms were found to be contaminating underground water supplies with toxic chemicals stored in a leaking underground containers. A water quality control agency ordered the company to take immediate corrective actions and contribute to some kind of testing and cleanup to the underground contamination. Suppose that require this many millions of dollars given by this function. So we have a function. We do have to be careful this time because they restrict the x value is between 0 and 1. That's all we want to care. So we only focus on really small piece of the graph, even though this is a rational function. So x is the percentage expressed in a decimal fraction of the total contaminants removed. And p of x, so they want to find where is it increasing and decreasing. So for that part, we probably need to do what? First derivative. So we need to find out what is that, where the graph is concave up and down. So for that, we're going to need the second derivative. Oops. Okay. And the horizontal and vertical line, we know how to find those. And x and y intercept, sketch the graph. Okay, so let's see. Interesting, they didn't ask the exact value and stuff. So, but we're gonna need to take some derivative, and we need to be very careful with that. It's very easy to make a mistake. So 81 p of x is 2x1 minus x. We only care about between 0 and 1. Got it. Okay, so found the first derivative. P pi of x, doing quotient rule, the bottom part need to be square. Start with the bottom part times the top part, take the derivative. Subtract the top part, take bottom part derivative. Got it. Okay, so this is 1 minus x times 2, right? Minus 2x. Take the derivative of that is 0. Sorry. And then I assume I just said it. And then take the derivative of that would be 1. So it's multiplying a negative 1. And then 1 minus x squared. Are we okay? And together we have 2 minus 2x. Negative times negative is positive 2x, and then 1 minus x squared. Look like we can cancel this part. So p pi of x equal to 2 on top, 1 minus x perfect square, right? So using that, we can find the increasing and decreasing stuff. But let me go ahead and find the second derivative. Let's see what we get. So second derivative, p double pi of x, again quotient rule, 1 minus x squared need to be square. And then the top part, the bottom part times the top part, the derivative, subtracting the top part times the bottom part, the derivative. We have to be careful, that's a chain rule. Okay, so this is good because you're taking the derivative of a number, it's going to turn into 0. So multiply a 0 is going to be everything go away times 2. I need to bring down the 2. 1 minus x, 1 less would be 1. Take this derivative of 1 minus x pi, chain rule. 1 minus x, this is square over square, is going to be 4. So this whole thing is 0, right? 0 minus 2. In here we have 2 times 1 minus x to the first power. This whole thing, this is 0 minus, we return to a negative 1. Okay, and then 1 minus x to the 4th power. All right, so clean that up just a little bit more. Really tired, right? So this is basically negative 2 times a 2 times a negative 1. Together we have positive 4, right? So positive 4, sorry, 1 minus x. At the bottom we have 1 minus x to the 4th. Look like we can cancel one of this. It's kind of difficult. So p double prime of x is going to be 4 on top, 1 minus x to the 3rd power. So we found the first and second derivative, right? Let's go back to the question. Maybe we just put it down over here and figure it out. So p prime of x was 2 on top, 1 minus x, perfect square. Second derivative, 4 on top, 1 minus x to the 3rd power at the bottom. So the top one, we can test the point. If we set top and bottom equal to 0, the only point we will get is like the point is going to be 1 minus x equal to 0, and then 1 equal to x. So can 1 equal to x though? If x equal to 1 minus 1 is 0, so x actually cannot equal to 1. So when I set this thing, x equal to 1 does not exist, right? Because it will make the denominator equal to 0. And they told us to test between 0 and 1. So this interval has to be between 0 and 1. That's it, right? We don't need this part because of the restriction. So test a number between there, maybe a 0.5. So if f prime of 0.5, plug it to your calculator or do it by hand. Hopefully you get a positive number. When f prime of x equal to positive, is it increasing or decreasing? So your function should be, oh, I'm sorry, you cannot see. Sorry about that. This question getting intense. I'm getting tired of this. Okay, sorry about that. So we were doing the first derivative. So we need to set the top part and bottom part equal to 0. Top part say 2 equal to 0, which doesn't happen. 1 minus x equal to 0, we solve for that, x equal to 1. But if x equal to 1, it's going to make the denominator part equal to 0, so that part does not exist. And the reason we don't need this part is they restricted x between 0 and 1. So I only need to test between 0 and 1. When I plug in a 0.5 for my first derivative, I got a positive. So first derivative, positive means the function is increasing. So increasing between 0 and 1, but no decreasing. Okay, the second derivative, again, if you set 4 equal to 0, that doesn't exist. This would be x equal to 1. Again, x equal to 1 does not exist either, but that's my point. Does not exist. Okay, and then it has to be between 0 and 1, so this part doesn't exist for our question anyway, and this would be 0 to 1. Let's see. And we need to test the second derivative, say 0.5, and that, if you plug it in, will end up with a positive. When you do the second derivative and you have a positive, what does that mean? It means concave up, because it's positive, people smile, right? So concave up is between 0 and 1. Okay, so that's the increasing, decreasing, concave up and down, horizontal, vertical asymptote. So vertical asymptote, using the original function, you set denominator equal to 0, right? So 1 minus x equal to 0. At x both sides, x equal to 1 is my vertical asymptote. And then for horizontal asymptote, it's just like y equal to the leading coefficient on top and leading coefficient at the bottom, right? So y equal to, this is 2x negative x plus 1, right, basically. So we got this part. And horizontal asymptote is going to be y equal to 2 over negative 1, which is y equal to negative 2. So your books say none because like after we graph this, this is not on the scale. So the book will say none for this. Okay, so let's sketch the graph. Okay, if we sketch the graph, let's do it here because we have all the information here. Maybe this is a little bit confusing. Sorry about that. This is one of the most difficult questions for the semester, I think. So need to be stressed out with all this information fitting on the screen. Have a little bit difficult time. So we're gonna try to sketch it, and then because we only want between 0 and 1 for x, and then x equal to 1 is a positive vertical asymptote. Okay, so you have that, and the graph is going to be concave up between here, so it's going to be something like this. And the y equal to negative 2 is down here, so it's not quite in the graph, so they say none. But if you really want to draw it, it would be y equal to negative 2. All right, so I know this one is kind of complex, but we want to show you an example. I think you have a similar homework question, so hopefully this helped a little bit, but this section is pretty difficult. So if you have questions, please be sure to email me and let me know, okay? And we also have the tutor.com for the commerce students, so you can do that also. Thank you.